Hello guys, let's solve this integral right here, but we're going to be using only substitution method and no other methods. And I asked you in the title about how many methods did you come up with to solve this using just substitution, like how many different substitution methods did you come up to solve this integral right here. I came up with 4 personally, and I'm going to show you those 4 methods right here. So first, I'm going to begin with the most odd one out, the trigonometric substitution. So I'm going to let x equals to sine theta, and differentiating it will get cos theta d theta. Now, I chose sine theta because here this will become 1 minus sine squared theta, which is just cos squared theta. And we can just do the trigonometric integral, right? So this one, it becomes sine cube theta, dx becomes cos theta d theta. Now obviously you can also choose cos theta instead of x, and differentiating it you'll get minus, and you'll have to deal with the minus signs, which should not be that much of a problem, but this is just easier and faster. So as I mentioned earlier, this is just 1 minus sine squared theta, which is cos squared theta, and since that is under the root sign, the square and root will cancel, giving cos theta. That and that cancels. So we're going to have to find out the integration of sine cube theta. Now, we're going to have to go to the multiple angle formula. So you guys will have to know that sine 3 theta is equals to 3 sine theta minus 4 sine cube theta. Now if you want a proof, you can just do sine theta plus 2 theta and then apply the formula for sine a plus b, and then you'll get this. And let's just find sine cube theta directly. So sine cube theta, we put that here, put that there. 3 sine theta minus sine 3 theta whole by 4, right? Put that there, this goes there, divide by 4. So that means we'll have 1 by 4 outside. Let's just put that outside. Integration of 3 sine theta minus sine 3 theta d theta. So we can just do it directly. So integration of sine theta, which is just minus cos theta. So this is just 3 or minus 3 cos theta minus sine 3 theta. Integration is minus cos theta by 3, and minus minus will be plus cos 3 theta by 3 plus c, and we're just going to have to put it back into x. Now as you can see, we have cos theta over here, and we started with sine theta, so that means we need to figure out what cos theta is, and we can do that by using the right angle triangle. So let this be 90. Let this be a right angle triangle. This is our hypotenuse. Let this be our angle. This is perpendicular. This is base. Now let's use what we substituted. We had sine theta is equals to x, but we can rewrite x as x by 1. And from our most basic knowledge of trigonometry, we just know that sine theta is the perpendicular by hypotenuse. So that gives the perpendicular as x, hypotenuse as 1, and we just need to figure out our base, which is just root over h square minus p square, which is 1 minus x square. So that means we can find our cos theta, because cos theta will be first base by hypotenuse, which is root 1 minus x square by 1, right? And now what about cos 3 theta? Well, is it just root 1 minus x square into 3? No, because here we have to again use the multiple angle formula. So cos 3 theta is equals to, similar to that, it is 4 cos cube theta minus 3 cos theta. Just switch these positions together, right? And then here, now we can actually put this over here. So cos 3 theta becomes 4 into cos cube theta, which is root minus x square whole cube, which I'm going to put it as power form like this, minus 3 root 1 minus x square. So this becomes 1 by 4 minus 3 root 1 minus x square plus 4 into 1 minus x square 3 by 2 minus 3 root 1 minus x square whole by 3 plus c. And we can just clean this up a little bit. So first we can just do that and that, or we can just directly open up the bracket. So first this will be actually no, let's just put the 1 by 4 outside. So this will still be minus 3 minus x square plus this will be 4 by 3 1 minus x square to the power 3 by 2, and 3 cancels, giving us this. And here you can see these two are the same, so that means they can just add up because they both have minus sign, so they become minus 4 root 1 minus x square. So I'm going to rub this out. So this will be 1 by 4. I'm going to put this in the front because it's positive. 4 by 3 1 minus x square to the power 3 by 2 minus 4 root 1 minus x square plus c. And we can just nicely cancel out the 4 and 4. So this is just 1 by 3 1 minus x square to the power 3 by 2, and this we can also cancel, minus root that plus c. And there we go, that is our answer over here. And also for the other 3 methods as well, we should get the same answer because it came from the same integral. So let's start off with the second method. So let's let u equals to the whole under this root, so 1 minus x squared. Now this will become root u, but we have to find dx. So here, differentiating both sides, we'll get u equals to minus 2x dx, and dx will be equals to minus du by 2x. So again we have the x over here, but we purely want that to be in terms of u. So from here we can get that x equals to 1 minus u whole root, right? It goes over there, that goes over there. X squared equals to 1 minus u, and just root both sides, x equals to root minus u. So this is just root 1 minus u. Now put that in this integral, you have x cubed. So x cubed will simply be 1 minus u to the power 3 by 2. So you'll get 1 minus u to the power 3 by 2 into minus du by 2 root 1 minus u, and well, we have 1 minus u and 1 minus u. We can somehow cancel that, right? Well, instead of to the power 3 by 2, what if we just write it as 1 minus u multiplied by root 1 minus u, because that's what 3 by 2 is, right? Because this is to the power 1, this power a half, and 1 minus a half is just 3 by 2. This whole by root 1 minus x square. So as I mentioned earlier, it's just root u. So this and that will cancel out, and let's just put this minus and the 2 outside. So this will become minus 1 by 2 integration of 1 minus u by root u du. And it is simple from here. You just have to separate this numerator over here. So this is just minus 1 by 2 the integration of 1 by root u, which is just u to the power minus a half minus u by root u, and u is just root u whole square, so that and that cancels, giving us root u, which is just u to the power 1 by 2 du. So simply this is u to the power minus 1 by 2, its integration. So it will be u to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1, power rule. And this will just be 1/2, this will also be 1/2. And this 2 1 by 2 in the denominator it will just become 2 on the numerator, and this will just be root u, right? U to the power half is just square root of u, minus u to the power 1 by 2, so just plus 1, 1 by 2 plus 1, this will be 3 by 2, and again this will be 3 by 2, but 1 by 3 by 2, just switch the 3 by 2, it will be just 2 by 3, and u to the power 3 by 2, so yeah, plus c, and well, you can just multiply it out. So in fact this is just, in fact I'm also going to multiply the minus at the same time. So this will be minus root u, I'm going to put over here minus root u, but let's just directly substitute that in as 1 minus x square plus c, and minus minus plus, 2 cancels, giving us 1 by 3, 1 minus x square to the power 3 by 2. So we got the same answer as the first method, and let's quickly move on to a third method right away. Now in the third method, I'm just going to be using u equals to x square, or substituting u as x square. Now this just shows how interesting this integral is, because you let u equals to 1 minus x square, you'll get the answer. You let u equals to x square, and you'll also get the answer. Let's see how. So differentiate both sides, we'll get 2x dx, and dx will be equals to du by 2x. But we don't want to see the x with u, with du. We want to see u with du. So let's just put x in terms of u. So from here, easily x will be equals to u root u. Put that over here. Now see the integral. We need x cube in the numerator, and from here just cube both sides. You get x cube is equals to root u whole cube, which is just u to the power 3 by 2. Now this becomes u to the power 3 by 2 by, this is just root 1 minus u into dx is just du by 2 root u. Now you can solve it in two ways, but I'll do the nicer way. So u to the power 3 by 2, you can just rewrite it as u into root u, as I explained in the second method, and root u cancels, giving us u by root 1 minus u du. Now since they are both linear, or let's just say for the same power, we can just put the numerator as in terms of the denominator by, well, introducing the numerator in the numerator. We can do that by, first we see the minus, so just make that minus, and we see the 1, just add the 1, and since we added 1, just subtract 1. So this integral is just equals to that integral, right? Wait, I forgot one thing. This by 2, I'll have to put it outside. Very crucial step. Now this is just the integral of, just split the numerator from here. This will be 1 minus u by root 1 minus u, which is just root 1 minus u. But let's write it in terms of power, because we can just use the power rule here, because u, or this is a linear term, and this will be that. So this is so much like the second method, but instead of 1 minus u, we just had u, but we just let x squared equals to here. So you can see where we're going with this, right? And minus 1 by 2, and let's just do the integration right away, because we did it in the second method. So this is just 2 by 3, 1 minus u to the power 3 by 2. But be very careful. You can see we have a minus u over here, and you will have to divide it by minus 1, because that is the coefficient of this u right here. So this will just be minus, and this similarly will be plus 2 root 1 minus u. You can just see the second method for this, right? And just multiply it out. This will simply be 1 by 3 over there 1 minus x square to the power 3 by 2 minus root 1 minus x square plus c, and that is it. And a very important step is from this to that, doing the integration of this and remembering that you will have to divide by the coefficient of u, because you can get confused so many times and get root minus x square minus this whole part. Now let's move on with the second method. I meant to say the fourth method, and let's begin right away. And here what I'm going to be substituting is whole of this denominator instead of just something under the root. So I'm going to let this whole denominator as u, and it will still work out. This is so fun. Now differentiate both sides, but it will be very crazy like that, so let's just square both sides. You get u square equals to 1 minus x square. Now you can differentiate both sides. You get 2u du equals to minus 2x dx. So here the 2 and 2 cancel, so just erase that, and we want dx in terms of du, so dx will be minus u by x du. But here we don't want to see the x with du, we want to see x in terms of u. So let's go over here, and here x is equals to root 1 minus u square, right? Just put x square over there, u square over there, root both sides. Now just replace that as 1 minus u square. So this is the integration of x cube. We have x cube in the numerator, so this will just be x cube will just be 1 minus u square to the power 3 by 2, right? So this is just 1 minus u square to the power 3 by 2 by u, just u, into minus u by root 1 minus u square. So the substitution part and then doing the differentiating, that is a bit complicated than the others, still very simple, but the integration is very beautiful, because here u and u cancel, and also here this you can rewrite it as this into that and that cancel. So all you have to figure out is the integration of 1 minus u square du, right? And which is just going to be minus u plus, this is just u cubed by 3, or sorry, minus, and then just multiply the minuses out, substitute that in, you get 1 by 3 1 minus x square to the power 3 by 2 minus root 1 minus x square plus c, and that's just because we multiplied the minus and then substituted back in, and there we go. That is my 4 methods, and let me know how many methods did you come up with by using only substitution. And if you learned something new, please like and subscribe. Thank you.